A warm welcome to all attendees for the product release webinar on the Tasking VX toolset for ARM version 6.0 release 1. My name is Florian Süßmar. I'm responsible for product marketing at Tasking and will be the moderator for today's webinar. During the next 30 minutes, our field application engineer, Mohamed Suher, will provide an overview of the extended VX toolset for ARM with support for the Travio 2 series of microcontrollers from Infineon. Suher will guide you through the main features and advantages of the new compiler toolchain. As a recognized leader in high quality, functionally safe, and security compliant embedded software development tools, Tasking allows you to create best-in-class code size and performance with compilers, debuggers, and RTOS support for industry-leading microprocessors and microcontrollers. Now let's have a look at the Tasking portfolio. The Tasking embedded software development solutions provide an industry-leading ecosystem for your entire software development process. In addition to the VX toolset for ARM, you can see here on the slide, Tasking is offering toolsets for both the Oryx, TC2X, and TC3X families, as well as supporting the third generation of the Oryx family, the TC4X, with our brand new smart code development environment. The tri-core toolchains are ASPICE Level 2 compliant, conform to the ISO 21434 cybersecurity standard, and are TÜV certified according to ISO 26262 up to ASIL-D. If we move forward to the Tasking performance tools, Embedded Profiler and Multi-Core Performance Tool provide fast and efficient access to flow tracing information to resolve stalls, cache misses, cross-core memory accesses, and provide guidance on how to reach a safe and equally distributed core load in your multi-core system. The Tasking safety security ecosystem includes the safety checker, a static analysis tool to ensure that freedom from interference is maintained in ECUs with software components having different ASIL levels. The Tri-Core Inspector provides embedded system developers an automated method for identifying if any SIL 2, 3, or 4 toolset related issues are in their compiled output code. And finally, the Tasking offers qualified C math libraries per ISO 262, as well Oryx optimized LAPACK performance libraries to provide rapid and accurate solutions for your complex mathematical operations. For hardware configuration and Oryx port mapping for your PCB development, the Tasking pin mapper completes the portfolio. This webinar will be recorded and available on our website at the link shown below in the next couple of days. We also invite you to review our previous webinars as well as our library of application notes, white papers, and tips and tricks videos, which are available also on this website. In case there are any questions during the webinar, we invite you to use the Q&A function on your Zoom console. All questions will be answered at the completion of the webinar. Now let me introduce the speaker of today's webinar, Mohamed Suher. Suher is an electronics engineer with over 14+ years of industry in developing, testing, and in automotive electronics. He has worked on various functional safety compilers supporting OEMs, tier ones, and in automotive semiconductors. And currently, Suher is working as a field application engineer for Tasking, supporting a wide range of customers for the India region. His area of interest is on the multi-core with focus on safety and security in the automotive domain. And now I will hand over to Suher.
Thank you, Florian, for the kind introduction. Hello, everyone. Thank you for taking the time to join our webinar today. I welcome you all to today's presentation. Now let's get started. Many body applications which were considered not safety critical a few years ago or looked at from a different perspective today. For example, a seat heating module could be argued to be an SLA because seat overheating could cause injury to a passenger during driving. Another example involves a key fob. On some luxury vehicles on a hot summer day, as you are walking to your car, you can open the windows to aerate the vehicle before you arrive. In such an application, you need a microcontroller with low operating current so the application does not drain the battery quick. It also needs to provide switch inputs, safety, cybersecurity, and high performance. Safety and cybersecurity requirements specified by ISO 26262 and ISO 21434 can add additional code and complexity in the system, thereby increasing the code size or reducing the performance. Choosing the right compiler for such safety and cybersecurity application is very much essential. From a business perspective, it is a goal of a system developer to use a lower cost microcontroller with efficient code that does not take up a lot of space, allowing the code to be placed in a smaller memory footprint. Many OEMs and tier ones are taking the advantage of the tasking wiper technology to significantly reducing the code size and still meet real-time requirements of the system with the high performance code generated by the toolset. Tasking optimization routines generate smaller code which could let customers take advantage of a cost-effective, lower device instead of an expensive, higher performance microcontroller. You can take advantage of tasking optimization routines to make your source code smaller so that you can work out of a smaller and cheaper device, and that's the advantage for you as an electronic designer. To make sure your code fit optimized and runs efficiently on the microcontroller for ARM-based application, Tasking has now introduced a new compiler toolset for ARM. As you know, Infineon and Tasking have been working together for many years on the software development tools for the Tricore and Oryx, which may be for TC2X or a 3X or a TC4X. So thereby Tasking is already covering a large portfolio of automotive embedded applications like ADAS, powertrain and EV, chassis and safety, which are purely Oryx based. With Infineon's new addition of microcontroller, Trevio T2G, supporting body electronic applications like driver information and body and connectivity, Tasking has now extended its toolset to support ARM-based development also. We now offer toolchains supporting both Infineon's Tricore and Trevio T2G microcontrollers portfolio. It is important to notice that the Trevio T2G takes less current, where it fits better into the body controller applications where the microcontroller must be up and running in a queue-off scenario. However, there are numerous safety features inside of the Trevio T2G as well, so that it can bleed over into other space where Oryx is used in body controller application and Trevio T2G is used in some safety applications. But the overall message is that we can now work on the entire vehicle with most of the Infineon portfolio. Compilers for both Trevio T2G and Oryx are now available from a single tool partner. This simplifies that the work of users who use both Oryx and Trevio T2G microcontroller for their automotive applications. Well, the added advantage is that apart from supporting automotive applications, any new customers developing industrial application with Trevio T2G can also now get benefited from our new Tasking VX toolset for ARM. Now let's explore our new tasking VX toolset for ARM Cortex-M. Tasking has the newest member of the ARM family of software development tools, version 6.0 R1. In fact, the previous version was also available. The toolset is based on our own proprietary Viper technology. It comes with a C and C++ compilers, and it is based on 64-bit Eclipse IDE. What is a great advantage? It provides the same user experience as a well-known VX toolset for a Tricore and Oryx. When it comes to a platform support, we have a support both in the Windows environment as well as on the Linux environment. The users who are working on the Linux environment can also make use of this VX toolset for ARM Cortex-M. The toolset provides the same user experience as I already mentioned. Once if you're already working on the VX toolset for Tricore, so you are ready to go with this also. Our ARM toolset support the libraries defined by the ARM application binary interface. Toolset has an ARM instruction set simulator that supports the single core debugging as well as the integrated multi-core debugger. The main advantage is that the toolset supports RTOS-aware debugging so that the user can use the kernel support module that are shipped with this toolset and generate OSEC runtime interface. In short, we are calling that one as an ORTI file, which you can enable the debugger to become OS aware. So this tasking VX toolset for ARM Cortex-M is suitable for developing automotive applications up to ASIL-D, and it is also suitable for developing industrial applications up to SIL-3. We have a plan of getting TUE certification also for our toolset latest by this year. Let's take a look at some of the advanced features. So in this tasking VX toolset for ARM Cortex-M, we have a highly configurable linker with versatile script language for optimal memory control. With this linker script language file, you can specify the characteristics of your target board. And also with this linker script language file, you can specify how sections should be located in the memory. Also in this toolset, we have an integrated MISRA-C and CERT-C code checking capabilities. For example, if you want to comply your source code with that of a MISRA standard like a MISRA-C 2004 or a MISRA-C 1998 or a MISRA-C 2012, you can easily comply your source code with the integrated MISRA-C or with that of a CERT-C coding standard. So in short, so I can say that so there is no dependent on the third-party static analysis tool. And also we have integrated runtime error checking capabilities. So you can able to detect the runtime errors like bound checking. You can report unhandled case in a switch statement, malloc consistency checks. You can also check for the stack overflows. And in fact, you can also generate a code for division by zero errors also. So in short, I can say, so there is no need to depend on the runtime, so dynamic analysis tools also. Both the static analysis as well as the dynamic analysis tool is integrated with this tool set. And we have a support for the Cortex microcontroller software interface standard intrinsic functions. So with that, the processor abstraction layers grant user access to source and header file for almost every peripherals on that device. You can also import some of the examples which are by default shipped with the ARM toolset. And these examples are based on the Trevio T2G sample driver library version 6.6.0. So with these examples, it simplifies your development on the Trevio T2G devices. When it comes to ARM architecture support, ARM toolset supports ARM v6m, ARM v7m, and ARM v7 EM architectures. In turn, we can say it offers complete support for all the latest Cortex microcontrollers, including M0, M1, M3, M4, and M7. Tasking also provides the startup code, register files, linker script language file, and the header files so as to make the life of a user easy. Assembler support multiple ARM architecture and the operating modes, which includes ARM or ARM plus thumb and thumb 2 instruction, or it may be a combination of thumb and thumb 2 instruction. Tasking VX toolset for ARM provides support even for the heterogeneous combination of microcontrollers. As you can see, the CPU subsystem example of the Trevio T2G that has a dual Cortex M7 and a single Cortex M0 Plus. This table here is a summary of ARM Cortex M support. So the table gives you the main characteristics of ARM. It also tells you about the operating mode supporting thumb instruction and data catches combination specific to microcontrollers. And it also gives you information regarding instruction and data tightly coupled memory. Our ARM toolset provides advanced multi-core compiler and linker support for explicit allocation of functions and data objects in tightly coupled memory also. And if you see the last row, it shows our ARM toolset supporting ARM cores with various microcontrollers from different chip suppliers. The Trevio T2G's CYT4 series, if you take, it has 2 Cortex M7, and Tasking has implemented a support for integrated dual core CM7 projects via the virtual core, which allows you to take advantage of tightly coupled memory through which you could avoid memory latency. Trevio T2G Cortex M0 is dedicated to security as a hardware security module to support secure applications in connected cars. And it is also used for secure and authenticated boot, protection of keys and certificate, and firmware authentication for firmware over the air. In general, if you see, the Cortex M4 and M7 are used for applications like automotive, IoT, motor control, power management, embedded audio, industrial and home automation, healthness and wellness application also. Also, the Trevio T2G's Cortex M4 and M7 are used for applications like motor control for hybrid and electric vehicles, body and connectivity, chassis and safety. So once if you have installed our ARM toolset and if you want to create a new ARM project, so this is a perspective in which you come across where you have an option to select by means of an architecture. As I already mentioned, so we support ARM V6M, V7M, and V7EM, and you also have an option to select by means of a core, or you can select different microcontrollers from different chip suppliers. Different architecture provides obviously different real-time performance. For example, if you choose a Cortex M7, it provides a higher operating frequency, therefore lead to better time determinism for more advanced application based on complicated algorithm, which requires things to be done in fast and time expedient manner. So let's move on to the next slide. This is a perspective view. Once if you have created your project or once if you have imported our example projects. So there are a lot of example projects available. And once if you have imported our example projects for the Trevio T2G with SDL support as shown in the example. And the most important thing is, so these are powerful toolbar weapon where you can play around how to create a new project. So, and how you can manage the project configurations. For example, if you have a multiple configurations for the same project, you can play around with this toolbar. You can able to manage the debug configuration. You can build and rebuild your project and so on. All the skills are based on Eclipse and are similar to our VX toolset for a tricore. So that's why you don't need to learn anything new. It provides a very user-friendly interface. And finally, so that's a debug view perspective for you, where you can have a memory window. You can play around with the registers by having a register view window. You can also see the breakpoints, variables, and expression window, and to see how the variables are getting updated as you step through a debugging. And the main thing is so disassembly view when you are on a deep debugging mode. And this your debug mode weapon where you can suspend a particular code. Obviously, if you're working on any of the multi-core project like a CYT4 series where you can see a lot of cores. Apart from CM70, you can see CM0 and CM7 also, where you can suspend any particular core and you can run a project till a breakpoint. You can step through or you can step out for a lines of code. In fact, you can also restart a project and reinitialize the device. So that's a bird's eye view of how you can connect ARM toolset with your microcontroller and debug. So the example what we have used here is a Trevio T2G CPU board CYT 4BF series. You can make use of our tasking VX toolset for ARM Cortex-M to generate your binaries through our compiler, assembler, linker, and locator. With the help of Segar J-Link base as shown in the image, you can flash the ELF onto your favorite supported microcontroller, and the rest you know how to debug your code using the IDE with the register views, memory dump, as well as a disassembly. As I mentioned already, you can also generate the OSEC runtime interface or file, which is a ORTI file, with the help of our kernel support module, and you can easily import your ORTI file into the debug configuration of our toolset. So thereby you can have a kernel aware debugging. You don't need to spend too much money buying a debugger. Just you can click on this link, which takes you to purchase the Segar J-Link base version, which cost you around $400. In fact, you can also make use of the third-party debuggers. And you can also make use of the advanced version of the Segar J-Link, like a J-Link Trace or some other J-Link version. But the base version should be more than enough to do this job. Finally, here comes the licensing terms of the VX toolset for ARM Cortex-M. We offer you 3 types of license. One is the evaluation license for a term of 30 days, which is purely free. And there is a time-based and the continuous integration license, which comes with a half-year term or a 1 full year. Support and maintenance is included and it is a part of the license, but we support and assist you for free when you are on the evaluation phase. In fact, whatever the license you want, whether you need a node lock license, whether you need a floating license, we can provide you any of this. In fact, you can see in this tasking VX toolset for a ARM Cortex-M, safety manual is included in that, and there is no additional cost for a qualification kit. So that's a great advantage for you once if you make use of our tasking VX toolset for ARM Cortex-M. So let me take you to my last slide of the presentation. So these are all the key takeaways. So there exists a high level confidence in the use of our tasking VX toolset for ARM. We have followed a mature development process combined with the rigorous testing using perennial test suites. Tasking being one among the software supply chain, we have made sure the toolset we provide can be used to develop software applications up to ASIL-D, and it is on par with ISO 26262 and IEC 61508. As I already mentioned, we have a plan of getting to UE certification later by this year. So we also have a safety manual included. Once if you start developing your functional safety related development, it may be of very useful to you. Our user-friendly ARM toolset provides the same experience as our well-known VX toolset for a tri-core. So that's why you no need to learn anything new. And the toolset is compliant with the industry standards, supporting C11 as well as a C++14 defined by ISO and ARM ABI. Our toolset supports new multi-core ARM products of Infineon, the Trevio T2G device. We also provide advanced debugger features with ARM instruction set simulator. Even if you don't have a hardware ready for your applications, you are good to go with our ARM instruction set simulator, where you can completely analyze your peripherals of your device. With the special support of AUTOS-aware debugging, the toolset learns about all the necessary information of OS components, thereby providing the user with stress-free OS debugging. And we also support for the CMSIS, which is a major advantage for you, where you will have the flexibility to access all the hardware abstraction, and it also eases your task for the software development. So there are many Trevio T2G devices example based on the sample driver library, which provides driver for an extensive set of peripherals and provides CMSIS compliant device header files, startup code, and device configuration files to simplify your development process. Finally, let me urge you to get in touch with us and get your free evaluation license and test drive with your own code. Now I will hand over back to Florian and he will guide you further.
Yes, thank you very much for your presentation, Suher. As you just mentioned, if there's anyone interested in an evaluation license and there was already a question how you can request, you can have a look at the following contact informations. You can either contact us directly via our website. There will be a web form, just fill it out, and a sales representative will be directly get in touch with you, or you can choose to follow us on LinkedIn. Also in China, for Chinese colleagues and people there, we have a WeChat channel, and you can also sign up to get the latest news from tasking on our subscribed web form fill. So now it's time for you to ask questions. Suher will be happy and myself to answer all open questions. Okay, there is also a question if I would like to ask some question about TC399 HSM, who can I contact? You can also contact us via the contact form, and we can either one of our experts, technical experts, can answer this question, and we can also find a contact at Infineon who can support you with this.
Yes.
Then there is another question. How does the new version of the Tasking VX toolset for ARM differ from the previous version?
Yes. So this new version is suitable for automotive and industrial application development, supporting ISO 26262 up to a SIL-D and IEC 61508 up to SIL-3. As I already mentioned, so in this new version of VX toolset for ARM Cortex-M, we have a safety manual included in that, which provides you the complete guidance and evidence to support the qualification of the tasking VX toolset for ARM. So in accordance with your safety standard. And also, as I already mentioned, we have a TUE certification plan for this year. Okay.
Then there's another question. Who should we speak to for getting started support? So the user seems to have some license problem. So also in this case, you can contact our support team, support@tasking.com, and then our experts will directly get in touch with you and support you with getting started. And also if I have a license issue, then they will support you here.
Yes. Yeah, in fact, once if you go to the help help tab, and you have a welcome section over there where you can find a lot of projects. Okay, in fact, you could not able to find out, so we can help you out with that. And also related to the licensing problem, as Florian has mentioned, you can write an email to support@tasking.com.
Exactly. Then there's another question. Can I run the tool from command line?
Yes, in fact, you can also run directly from the Eclipse environment, and you can also run from the command line. Just you need to make use of our control program, CCARM, and you need to specify the CPUs, the processor details, as well as the linker script language core and the new task option. And you are good to go in that.
Thank you, Suhail. Any more questions? Feel free, we still have some time. We will be happy to answer any questions. Yes, there's another question popping up. What debuggers can I use?
Yeah, as I already mentioned, so you have an option to make use of any of the third-party debuggers. Once if you have the tasking .l format, you can make use of any of the third-party debuggers. So in fact, so once if you have a minimal debugger like a Sigger Jilling, you can make use of it and you can flash it onto your target board. And even if you are making use of any third-party debuggers and if you face any difficulties, you just let us know. We are happy to support you.
Okay, thank you, Suhail, for answering this question. Any additional questions from the audience? So it seems like there are no further questions. No more questions coming up. So thank you very much for participating in this webinar. And as mentioned before, please feel free to contact us anytime if there are any questions regarding our latest ARM toolchain supporting the Travio 2 family from Infineon, or if you have any other requests in regards to any other tasking products, just contact us and we will be happy to support you. Also, this webinar will be recorded and will be available within the next 24 hours on our website, so you can share or watch the recorded version again. And thanks again for joining, and thanks, Suhail, for your presentation. Have a nice day, everybody.
Thank you, Florian. Thank you all for attending this session and have a nice day.